Near-far choices in the ocular plane. J. Tarrant. Size 635, Research Design and Methods. Dr. Amy Price, 29 January 2024. The fovea, which is Latin for small pit, is used to refer to both the area of the retina in a mammalian eye that forms the center of an image and the center of the visual field when discussing the overall image as perceived by a human with unimpeded vision. The periphery refers to the rest of the visual field. fMRI images suggest that both the fovea and the periphery are controlled by the foveal retinotopic cortex. This part of the brain is also responsible for object discrimination in both parts of the visual field. The foveal retinotopic cortex uses a process known as transaccadic learning to develop hierarchical rules for matching sensory input with the appropriate cognitive processes. My research question is, does the use of optical sights exclusively hamper the ability to discern targets in the near focal plane? The use of magnification hampering an individual's ability to shoot things is not a question simply for the military. A similar dysfunction can be observed in the ever-rising ubiquity of rear-end collisions on the road as smartphones and internal infotainment screens become ever overutilized by drivers. Rear-end collisions are currently the most common type of collision in the United States. The following literature is critical to understanding the process of the near-far visual plane calibration. Gutenferkner details the optokinetic nystagmus (OKN) and vestibular ocular reflex (VOR), two processes which allow the brain to adjust the visual field while moving and keep a continuous and uninterrupted image. Hominins, generally speaking, experience vision without breaks, despite there being a physical impossibility of actual unblocked vision inherent in the morphology of the human eye. Therefore, it is important to understand that continuous images are a cognitive function aided by physiological responses. Joshi et al.'s work measures the ocular following response, or OFR, in a series of experiments designed to demonstrate how OKN and VOR can be utilized to move the near-far visual plane in response to stimuli and show that this phenomenon does occur through the use of cognitive and physiological mechanisms. Piaget's book, The Grasp of Consciousness, details 15 classes of experiments performed on children of various ages designed to discover how the brain learns in forms and actuality. Piaget demonstrated a concept that he referred to as reflexive abstraction, which is the mental model that the brain forms to order the world based off of sensory feedback and the coordination of bodily movement to achieve results. The reflexive abstraction could be thought of, for the purposes of my research, as the hierarchical order the mind has developed through transaccadic learning to manipulate the visual field. I consider Stewart et al.'s work the overarching mechanics of Piaget's conceptualization through Stewart et al.'s discussion on transaccadic learning, with the first two papers discussing the refined neurophysiology that allow both the mechanics and conceptualization to work. The experiment will consist of 4 cohorts. All cohorts will consist of novice shooters. One subject cohort will be taught to shoot with the current method of utilizing an optical sight with magnification, the other with the traditional iron sights that consist of a rear aperture mounted to the back of the weapon's receiver coupled with a post toward the end of the barrel. Subjects will be given the Marine Corps Enhanced Marksmanship Program (EMP) qualification course. This consists of 944 rounds fired at distances from 5 to 50 meters from stationary and moving positions. This course is scored and will also be timed using a shot timer. The two groups of shooters' scores will be compared along with their overall time, along with the time to first shot for each course of fire. Comparison of these two will yield an objective score. Two more groups will also be given the same course of fire, however, their aiming method will be switched. Thus, a group who was trained on iron sights will be given the course of fire using a magnification optic, and a group trained on the magnification optic will fire using iron sights. Subjects will be interviewed before and after the course of fire. Before the experiment is run, subjects should be asked what they plan to aim at and how they plan to do, as well as open-ended questions about their understanding of and belief in the method they have been taught. After the course of fire, subjects will be asked questions regarding what they saw, how they aimed their weapons, and how they felt it coincided with what they had been taught. The use of visual aids, in effect, diagrams of what a sight picture appears to be, can be used to aid in subjects' descriptions. Teaching individuals to shoot to a high degree of competency does have the ethical risk of giving potentially unstable or dangerous individuals a lethal skill. Utilizing the U.S. military for this experiment should mitigate this risk to an acceptable level, as the military does, if imperfectly, attempt to screen for such negative predispositions and can provide follow-on services should they arise. Experimenting with a skill as fundamental to military operations as marksmanship poses the potential danger that when the skill is needed later in the subject's careers, they will not be able to apply it due to some unforeseen confusion. This seems unlikely, however, because both techniques being utilized experimentally either are or were in common usage during a multitude of combat engagements. The human visual field is controlled by a part of the brain known as the foveal retinotopic cortex. Biological movements are influenced by hierarchical rules, and these rules are developed via transaccadic learning. Adjustment of the visual field affects performance in real-world activity. What can be learned from studying how different methods affect the shooting ability of Marines has parallel application of improving the ability of drivers to avoid collisions due to improper concentration. L theme.